All right. So, hello and welcome everyone. Hello and welcome everyone to this particular session of JEE Advanced discussion. We are back again on today's topic, and today we are going to discuss about definite integrals, right? I hope you are all doing wonderful. Please let me know. Please give me a thumbs up in the live chat. Hello. All right. So, welcome back to this particular channel of Pradhan Academy. Already you had a class before this on chemistry. So, I hope that class was wonderful. So, now we are back again for discussion about maths, right? So today I'm going to talk about the definite integral. Okay. Now definite integral is one of the very important and crucial chapter, especially for JEE Advanced. That's why I'm basically trying to take this particular chapter into three takes. Okay. So I will be, this is a part one. This is a part one of definite integral, and in this part one, I'm going to focus more on the integer type questions. Okay. Because if you look at this chapter, you will see that there are a lot of different types of questions that has been asked from this particular chapter. Okay. So if you look into your previous year question booklet, you'll find there are a lot of different types of questions that has been asked from this particular chapter, especially of definite integrals, which basically means that this chapter is very important. Okay, so this is going to be part one, and where we are going to discuss about the integer type questions. All right. So before you start for the session, I all know that you already have cleared your JEE mains examination, so you must have done kind of good of revision for your JEE mains also, right? So from that particular discussion, let us carry forward. So again and again, I'm telling that before you start for this particular discussion on the revision of especially for JEE Advanced, I would request all of you to please go through your NCERT exemplar, and then please prepare a short notes, okay? Because short notes is going to be very crucial, especially for your exam a day before the exam. Hi Vikram, hi Vikram. Okay, so please prepare the short notes. This is going to be very crucial. Yes, Vikram, tell me. Yes, Vikram, tell me. All right. So today, carrying on this particular note, let us discuss about the previous year questions of JEE Advanced for definite integral, and we will practice the integer type questions only. Okay. So this is the very first question on our screen. All right. So give it a try. Everyone, just give it a try. All right. So let's first of all read through the question. So the question is talking about that if a function is defined from 0 to pi by 2 within the range 0 to pi by 2, and it is going to 0 to 1 as a codomain, and the function is defined as sine square x. Okay, so f of x is defined as sine square x. Now it is said that there is another function g which is again going from the same domain but a different codomain, that is 0 to infinity, right? And it is defined as square root of pi by 2 minus x into x, right? That is what is defined over here. Is this part clear? Yeah, hi Satyam. Thank you for your good words. I hope you are preparing for your exams. Yes, Satyam. How is the preparation for exam going on? All right. So carrying forward on this particular note, now it is said that we have to find out the definite integration from 0 to pi by 2 of f of x multiplied with g of x dx, and then subtracted with from 0 to pi by 2, and there is a 2 times over here, then integration of g of x and d of x, right? So if you look at this particular definite integral over here, how we can proceed with this question, right? That's a very interesting question over here. Now we're going to try to apply this particular problem by using some of the important properties, right? So if I look at the function sine square x, what I observe is that, so if I look at the function sine square x over there, now sine square x is going to be a even function, right? Now I'm not going to use the same particular property over here. What I'm going to think and apply over here is that, now if I see the change, that is 0 to pi by 2, right? So if I think of applying the most important property, that is, if you have any definite integral within the limit a to b for the function f of x dx, then it can be given as also as definite integral from a to b function of value of a plus b minus x dx, right? That is also possible. So this is what is called as the King's rule, right? So if I try to apply it over here for sine square x, and let us first of all call this particular integral as I1. Okay. Now if I apply this particular property on this first integral, so the first integral is going to also become 0 to pi by 2, 2 times, I'm not just writing the 2 times right now. So 0 to pi by 2, 0 to pi by 2, it is going to be, now in place of sine square x, and then we have square root of pi by 2 minus x into x. Now interesting part is that this particular function will remain as it is, right? If I do this particular replacement by a plus b minus x, this particular part of the function is going to remain as it is, right? But what is going to change is that, just let me check. Yes, so if I put in place of, so this particular part is going to remain the same, rather this particular sine square x is going to change to cos square x, right? Now in this way, if I take the sum of both the parts, then this sine square x and cos square x is going to come out as 1. So if I take the sum of 2 times of I1, that is basically going to be integral from 0 to pi by 2, it is going to be square root of, it is going to be simply the square root of pi x into pi by 2 minus x dx, right? And that is what is mentioned as 2 times of I, and I need to get this value of 2 times of I over here, right? That is what I assumed as 2 times of I over here, right? Now interestingly, if you find the 2 times of I, the 2 times of I is simply equals to integration of pi, integration within the limit 0 to pi by 2 for the function g of x. If you observe this, this is going to nothing become, but if I find out that integration 2 times of I, that is going to be 0 to pi by 2, 0 to pi by 2 times of the square root function of x into pi by 2 minus x into dx, and that is nothing but integration of 0 to pi by 2 g of x, right? That is simply integration of g of x. So what is more interesting to observe over here, that if I take the subtraction of 2 times of 2 times of integral I1 and subtract it from the integral 0 to pi by 2 of the function g of x dx, it is going to come out simply as 0. I hope this part is clear, right? So therefore, ultimately, we are going to have this particular answer as, simply equal to 0, right? So therefore, the numeric value of this particular result is going to be equal to 0. Is this part clear? So therefore, for this particular question, the answer is going to be equal to 0. Is this part clear to all of you? Yes? No? Anything? Is this part clear? Right. So if you look at this problem, the problem might look little bit difficult at the beginning, but again and again I'm repeating that the properties of definite integrals are very, very interesting. If you remember the properties, they are very, very useful for solving the questions in steps. Okay. So over here, if you see that if you just able to apply the property, this particular property, which is also known as the King's property, if you just able to apply that particular form over here, then the question is very, very simple in one step. Is this part clear to all of you? Yes, no, anything? Right? So I hope this part is making sense to all of you. Okay, so if you have any confusion over here anywhere, you can always put that in the live chat. And if you're watching the lecture or the live class is over, you can always put that the comments in the comment section. Okay, I will trying to answer your comments. All right. So with this, let's move to the next problem over here then. So the next problem we have with us is again a numeric type question, which is kind of a continuation of the previous problem, right? Now it is asking that we have to basically find out the value of this integration of 16 by pi cube integration within the limit 0 to pi by 2 f of x into g of x, right? Now if you look at this particular integral, we have already assumed as I1. We have already assumed this integral as I1, and the result we obtained is that 2 times of I1 is nothing but integration from 0 to pi by 2. We have it as square root of x into pi by 2 minus x and dx, right? That is what we have. Right, now we have to basically try to integrate this particular expression and then find the value of this integration multiplied with 16 upon pi cube. Is this part clear? Right. So let us try to see how we proceed for this particular part over here. Let us try to understand. All right. So please give it a try. Please give it a try. या हाई टेंशन सर आप मेरे दोस्त जैसे दिखते हो For real, sir, कौन सा कॉलेज है आपका? Yeah, you can all find this discussion in the description box. Okay, kindly go to the description box. You will find all those things. मुझे सुन के अच्छा लगा कि मैं आपका दोस्त के जैसा दिखता हूँ. Okay, you can find all the discussion in the description box. Okay, please go to the description box. You will find the discussion. All right, क्या समझ में आया सबको? Is this part clear to all of you? Right. So now let us see how we can proceed with this question over here. Right. So if I try to apply, now I can write this particular part of this part function over here. I can also write this part as, now in the integration 0 to pi by 2, this part I can also write it as pi by 4 whole square minus x minus pi by 4 whole square over here and dx, right? So I'm just simply apply the formula of a square minus b square. So if I do that, then you will find out that this particular result is going to turn out as simply as this, right? So if I am able to write this expression in this particular form, then I know the particular formula for it. Because if you recall, the integration of square root of a square minus x square dx is going to be equal to simply equal to x by 2 x by 2 square root of a square minus x square minus x square plus a square. Now if I have to take this x by 2 common, okay, now I have to take this, sorry, this half as common, okay, or else I can write as a square by 2, then sine inverse of x by a plus some constant, right? So if I just apply the same thing over here from 0 to pi by 2, the integration is integration of pi by 4 whole square minus x minus pi by 4 whole square dx. It is going to simply be equal to half times of x minus pi by 4 x minus pi by 4, and then there will be a x minus, so this is what I am assuming as a over here, right? So a part is going to be pi by 2, right? So therefore there will be a 2 coming over here again, okay, and then square root of pi x minus by 2 minus x square plus pi square by 32 then sine inverse of x minus pi by 4 divided by another pi by 4, right? That is what the value of a it is, right? That's why I have taken out 32. All right. So then I have to put the limit, that is 0 to pi by 2. Now if I put the limit, then the limit is going to come out. And now you have to be patient enough to solve this question. Okay. Might be the expression of the integral is looking very longer, but if you just have some patience and solve this by putting the finite limit, then you will get the value of this particular form over here as pi cube by 32 into 1 upon 2, right? So that is going to be equal to pi cube upon 64. So 2 times of I1 is going to come out as pi cube upon 64, right? So sorry, 32 over here. I have multiplied with half is because I have find out the value of I1, okay? So this particular part is the value of 2 times of I1. So from there I have divided by another half to get to this I1 value, right? So once I get the value of I1, then our final answer should be equal to, that is should be 16 by pi cube into I1, and that is going to be equal to 1 upon 4. That is going to be equal to 1 upon 4. Since the question is basically of in the decimal type of the numerical question, so you have to represent the answer as 0.25. I hope this particular part of the question is clear to all of you, right? Please let me know if this part is clear or not. Here's what I found. Right. Yeah, thank you, Tension. Sir, my friend and you both share a good subset. Okay, that's nice to hear that. Anyways. Okay, thank you. My friend is wise in maths. That's good to hear then. Is your friend preparing for JEE Advanced, Tension? All right. So I hope this part of the solution is clear to all of you. Tell me if you have any questions. Tell me if you have any questions. Any more questions? Oh, that's good. Okay. Also, Tension, you can share these videos with your friends also, so that they can also make the good benefit of these lectures, okay? Because these sessions are just for free on YouTube. Last he got 75 upon 100 in maths. Very good. But I have got 100 upon 100 in maths, okay? So, not a common subset. Okay, are you talking about the JEE advanced result? Or JEE mains result? Which one are you talking about? Okay, good. And what about you, Tension? Why are you not preparing? Alright, so I hope this particular question is clear then. Okay, any confusion, you can always put that up in the live chat. Hi, Ananya Mishra. Okay, alright, so let's move to the next problem then. So the next problem is a very interesting problem. Okay, now why I took this problem, just to show you that these kinds of problems might look very difficult in the beginning, but these questions are very simple to solve. Okay, you just apply one property and the question is very simple. Is this clear? Right, so please try to solve this question over here then. It is saying that the tan inverse of x the result of tan inverse of x lies within the interval minus pi by 2 to pi by 2, right? That is basically talking about the principal interval. Yes, respect mob. Let's put it on fate. I don't understand, Tension. Anyways, your name is Tension, so what do you want to have a fate as? Alright, so then it is said that there is a function f of x which is defined as 0 to x tan inverse of x, and then we have e to the power t minus cos t divided by 1 plus divided by 1 plus t to the power 2023 and then dt over here, right? So that is what we have over here. Now it is said that we have to find out that what is the minimum value of this particular function. So in order to find the minimum value of this particular function, I will try to take help of the calculus part. Okay, so I'm just going to use the principle that that we already know, that is basically maxima minima principle, right? So let us first of all differentiate this particular function and equate it to 0 to get the critical points. Okay, so first of all, I will do this particular expression in order to get the critical points. Right, so let us try to find out the critical points. Is this part clear? So if we have to integrate this particular, if we have to differentiate this variable definite integral, what I have to do over here is that I have to apply the Newton-Leibniz rule. I have to simply apply the Newton-Leibniz rule over here, right? So if I try to apply the Newton-Leibniz rule over here for maxima minima, then the Newton-Leibniz rule is going to simply turn out as so if I just try to find out what is my f dash of x, it is going to simply turn out as e to the power x tan inverse of x minus cos of x times of tan inverse of x whole divided by 1 plus x tan inverse of x whole to the power 2023, then multiply this differentiation of this particular upper interval, and that is going to come out as x into 1 upon x 1 minus x square plus tan inverse of x. That is what you will have as a differentiation of this particular function, and then minus 0, because the lower interval or the lower limit is going to be 0, right? So therefore you have the particular function, that is f dash of x for is equal to 0. Now we have to basically equate this particular thing to 0 in order to get to the critical points, right? So if I just equate this particular expression to equal to 0, the very first thing that you have to observe is over here is that e to the power x tan inverse of x cos of minus cos of x times of tan inverse of x whole divided by 1 plus x tan inverse of x, this particular function is always going to be equal to 0. So that it cannot be equal to 0, right? So the only responsibility for becoming 0 is basically of this particular part, that is x by 1 minus x square plus tan inverse of x should be equal to 0. So this part should be equal to 0. Now, when this part is equal to 0, that is when if you put x equal to 0, this particular part is going to be equal to 0. That is the only point where this particular function is going to be equal to the derivative of the function is going to be equal to 0 is only at x equal to 0, right? Now, from this particular part, therefore, if you see that f of 0 is going to be the minimum value, right? So f of 0 is going to come out as a minimum over here. Now you can check it by doing the second derivative at x equal to 0, which will turn out to be positive, and that basically ensures it is going to be minima, right? So therefore, the value of x where it is going to have the minima, also you can cross verify by taking out the critical point, and if you see about the 0, the sign change of the f dash of x is going from negative to positive, right? So this is the sign of f dash of x, right? Sign of f dash of x. So it is changing from negative to positive, right? It is changing from simple negative to positive, right? So whenever f dash of x changes from sign from negative to positive, it is basically indicating it is a point of minima. This is a point of minima. Is this part clear to all of you? Is this part clear? Hello, Sujay, Sunjay. Sir, should we do the solution of triangle because it could be used in coordinate geometry? Not necessarily. Okay, not necessarily the solution of triangle will be used in coordinate geometry. Okay, you will see that coordinate geometry is totally a different topics. Okay, you will have to learn a lot of different equations. You will play with different formulas also over there, right? The most important part in coordinate geometry you have to understand is that you have to be very familiar with the calculus part. Okay, because then your chapter will be very easy. Okay, because what you are going to encounter in coordinate geometry is basically you are going to work out with the graphical representative function, and then you have to find out the normals, the tangents, the chords, and all the important parameters, right? So that is what you are going to deal with the chapter of coordinate geometry. Okay, so it is not necessary to learn about the solution of triangles in order to do well in the coordinate geometry part. I hope this confusion is clear. Yes, Sanjay, is this confusion clear? All right, so sir, can you explain a single illustration of coordinate geometry? My dear Sanjay, this is basically a class for JEE advanced revision, especially on definite integral. Okay. So when we discuss about the preparation for different topics, I will definitely take up some illustrations. Okay. Don't worry, not only on Cengage or any other textbook that I have. Okay. I will take questions from general from anywhere. Okay. The questions are going to be very, very interesting, and they are definitely going to be of the JEE advanced level. Okay. So for this particular session, we are focusing on definite integrals. Okay. So please try to focus on definite integral now. When we come to coordinate geometry, we will definitely focus on it. Okay. And if you want to watch my previous session, I have already taken some sessions on coordinate geometry. So you can always check out the channel. Okay. Please check out the channel. Under the live tab, you will find up all the contents. Okay. Please go to the live tab and you will find out the content over there. I hope this part is clear to all of you. Right. Is this part clear to all of you? Okay, wonderful, wonderful. So now, therefore, the minimum value of this function is going to occur at x equal to 0. So if you put x equal to 0, the value of the function is also going to come out as 0. So therefore, the minimum value of the function is also equal to 0, right? So the answer to this particular problem is going to be equal to 0, right? I hope this is clear. Are you all getting the same answer? Are you all of you getting the same answer? Yes, no? Please let me know. Are you all getting the same answer or not? So I'm assuming this part is clear to all of you, right? Okay, wonderful. So let's move to the next problem then. The next problem is a very interesting problem. Okay, the next problem is a very interesting problem. It is talking about a very interesting phenomena that you will observe over here is that now this question requires a bit of practice. Okay, now these all types of questions and solution will obviously come from practice. Okay, so we see two different integrals over there. So let us assume the first definite integral as I1 and this is as I2. Okay, so let us try to first of all see what is I1. So I1 is going from 0 to 2, sorry, 1 to 2, 1 to 2, and it is natural log of base 2 x cube plus 1 dx, right? That is what is mentioned in this I1, right? And if you look at I2, the I2 part is basically integral 1 to log 9 base 2 2 to the power x minus 1 whole to the power 1 by 3. Now, what is more interesting to observe over here, if you consider this particular function as f, if you consider this particular function as f, what is more interesting to observe over here is that you will find out that this particular function is nothing but a representation of the inverse, is nothing but representation of the inverse, right? Can we just check it out? Is it true or not? So what I would suggest is that if you assume this 2 to the power x minus 1 whole to the power 1 by 3 as y, then 2 to the power x minus 1 is going to be equal to y cube, is going to be equal to y cube over here, right? Now therefore from here you will find out that your y part. So let me not make any kind of comment over here about inverse, okay, rather than not finding out, but I'm trying to give you the intuition behind it, okay? So if you look at this problem over here, it is basically y cube, right? Now what I'm going to do is that if I differentiate both the sides, what I'm going to get is that I'm going to differentiate. So I'm going to differentiate both the side. It is going to be equal to 2 to the power x into log 2 into log 2, right? So it is could be basically natural log 2. So I should write a log 2 base 2 divided by log 2 base e, right? Or sorry, I should write it as log e base 2, right? And then it is equals to 3y square dy upon dx, Now if I try to simplify it further, what I will get is that I'll get dx is equal to 3y square divided by 2 to the power x into dy over here, right? Now 2 to the power x can also be written as, this particular part can also be written as 3y square, and 2 to the power x can be written as y cube plus 1 from this particular relation over here, right? So now, and after that, it is basically 2 to the 3y square divided by y cube plus 1 dy, that is basically equal to dx, right? Now what you will observe is that when x equal to 1, y cube is equals to 1, that means y is equal to 1. So when x is equal to 1, y is equal to 1. Therefore, when your x is equal to log 9 base 2, your y is going to come out as, your y cube is going to be equal to 8, and therefore your y is going to be equal to 2, right? So what is more interesting to observe is that the second integral, if you change the integrand from dx to dy, what you observe is that it is basically going from 1 to 2, y into 3y cube divided by y cube plus 1 into dy, right? Now if I put y is equal to x, then the same things remain the same. So I can always change the integrand again. There is 1 to 2 integration of 3x to the power 4. So it is going to be 3x to the power, just let me check. Okay. Yeah, sorry, there is a mistake. Okay, it should be like, this should be 3x square, right? Yeah, so this will be 3x square. So this will become 3x cube divided by 1 plus x cube dx, right? So therefore this is basically the integrand or the integration I2. So the I2 is basically becoming like this, right? Now if I look at the I1 integration, and if I apply the by parts rule over here for this particular integration, by parts, right? If I apply the by part, this particular part is going to turn out as, this particular part by parts is going to turn out as log of x cube plus 1 base 2 into x with the limit 1 to 2 minus, I'm doing it over here, minus integration 1 to 2, this part is going to come out as 3x cube by x square plus 1 dx, right? It is just going to turn out at this particular form. Sorry, there will be x cube, right? This is going to turn out as simply of this particular form, right? Now there is one more, yeah, x cube is there, right? So this is what you observe is that now this particular I1 is turning out as log x cube plus 1 base 2 into x within the limit 1 to 2 minus I2, right? Minus I2. What you report is that this basically part is basically becoming as I2. So what you have to ultimately answer is that you have to ultimately answer as I1 plus I2. What is the value of I1 plus I2? So if you take this particular part on the right hand side, then I1 plus I2 is going to come out as x into log x cube plus 1 base 2 within the limit 1 to 2, and therefore if you evaluate this, it is going to simply turn out as, so it is going to be simply as 4 log 3 base 2 minus 1, 4 log 3 base 2 minus 1. Now because you have to answer what is the greatest integer value of this particular value, is that if you take a greatest integer over here, if you take the greatest integer of this particular thing, then it is going to turn out as, so 4 times of log 3 base 2. So now log 3 base 2, you don't have to remember the formula, but what you do is that you're just trying to manipulate, right? So natural log of 3 is somewhere around, so if you just recall, the natural log of 3 is somewhere around 0.6 and natural log of 2 is somewhere around 0.3, right? So this particular fraction is going to something like within the interval of 1.58, right? So if I take 4 times of 1.58, it's going to be 4 point something something, 4.2, something like 6.2 something, right? So therefore, if I take the greatest integer of that particular form, it is going to be equal to 6. And then if I subtract 1 from there, it is going to be 5, right? So ultimately, your answer is going to simply turn out as, it is simply going to turn out as, it's simply going to turn out as equal to 5, right? Now I have done this problem by just doing a manipulation with a change of the integral from this x to y. I was able to do this simply by, because this particular form are kind of very inverse of each other, right? Kind of inverse, right? So that's why I was able to do it, right? Now this particular problem can be done by just by assuming that this is f. If this function is f and this is f inverse of a, sorry, f inverse, then also I can assume this question, okay? In that case, I can also solve this question by very simple manner, right? So what I will do, if I assume this f dash f inverse of x is equal to t, then our f of t is going to be equal to x, right? So instead of solving for f inverse, I will solve for f of t, right? That is the only difference that you have to observe over here, right? So in this case, your dx, in this case, your dx is going to become t into f dash of t dt, right? Sorry, f dash of t and dt, right? Not t. Is this part clear? Right. So therefore, I have to solve this question in that particular manner also. I can always do that particular problem. Okay. Now I would leave that part of the exercise up to you to tell me what answer you are getting after you have done that problem by that particular way. Okay. Right now we are doing functions. When I was in class 11th, I used to be proud of myself for doing logarithm problem of J advanced. Very good. But sir, can you explain me why that was f inverse? Yes, for that you have to understand the inverse of a function. Okay, how to understand this? Because if you take this is, if you can understand, if you assume this particular function as y and you try to find out x in terms of y, you will find out that this particular function or the format is basically becoming like this. So this particular form is going to come out as like this follow. Is this part clear? Okay. So I hope this part is clear to all of you. All right. So that is all what we have to discuss in these questions of numerical type, right? So I am assuming that this part is clear, and considering this part is clear, let's stop our session over here, because there are questions on BT. See Sanjay, if you want to discuss questions of the numerical theory or the number theory for Olympiads, this is basically for J advance. Okay, we are preparing for J advance upcoming exam, but this is not for the Olympiad parts, right? So please make sure that, because for Olympiads I will take a different sessions. Okay, that is going to definitely come up. Yeah, no, it's not an issue. Okay, it is especially for the revision for the upcoming J advance. Okay. All right. So with this part, let us conclude our session over here. I hope this particular part is clear and you have definitely got the answers, right? All right. So with this, let us wrap up over here. Thank you for your attention.